In this video, I'm going to go through the solutions for worksheet number 4. So the first thing that we need to do is solve some different types of simultaneous equations. So question 1, part 1, x minus 2y equals 9, and 3x plus 7y equals 1. So when it comes to simultaneous equations, what we want to do is to kind of eliminate one of the variables, so either x or y, so that we can find one of them first and then use the one that we find to find the other one. This will make more sense as we go through. So I'm going to eliminate x first. So to do this, I'm going to multiply the top line by minus 3. So when I multiply minus 3 by the top row, I get minus 3x plus 6y is equal to minus 27. And the bottom row then is just staying the same. So this will cancel now because minus 3x plus 3x gives me 0. So that's always what I'm aiming for. Now I have 6y plus 7y gives me 13y. Minus 27 plus 1 gives me minus 26. So y is minus 26 divided by 13. So therefore y is equal to minus 2. So now that we've found one of the variables, we can't forget to find the other. So we use this to find x. So I take one of my equations, it doesn't matter which one. I'm just going to take the first one. And now I substitute in the value that I got for y. So x minus 2, for y we're filling in minus 2 equals 9. So x plus 4 equals 9, remembering that minus multiplied by minus gives us a plus. X is equal to 9 minus 4, so x is equal to 5. So we have two equations, we have two different variables, so we solve them simultaneously to find them. We find one value for x and one value for y. We know that these two equations represent two lines, so they're two linear equations. So this x and y value that we've found is our point of intersection. So the point of intersection is 5 minus 2. So now let's look at part 2. Again, we have two linear equations. We have 3x plus y equals 9. And we have x over 2 minus y is equal to minus 2. Now there's a few different ways you can approach this. Straight off we see that we could cancel plus y and our minus y because that will give us 0. But then we'll have to kind of deal with 3x and x over 2. We'll have to add them. One of the ways that you can kind of deal with the fraction straight off so that you can get rid of it is by multiplying the bottom equation by 2. If we multiply every term by 2 and get rid of the 2 on the bottom, it'll be more familiar to us and a bit more straightforward to complete. Okay, so that's what I'm going to do. So the top one is staying the same for the moment. The bottom one, I'm multiplying every single term by 2. So when I do this, the 2 is going to cancel above and below, so I'll just be left with x. Here, when I multiply it, I'm going to get minus 2y. And when I multiply 2y in my last term, I'm going to get minus 4. Okay, so I'm still not ready to eliminate any of the variables, but it'll just be a little bit easier to solve if we don't like having to add our 3x and our x over 2. Okay, so now I'm going to multiply the top line by 2. That way I can eliminate the y variable. 2 multiplied by 3x gives me 6x. Multiply 2 by y, we get 2y, and we have 18. And then the bottom line is staying the same. So now we can eliminate our y's. So because plus 2y minus 2y gives us 0. 6x plus x gives me 7x. So 7x equals 14. X is equal to 2. So again, I take one of my equations. It doesn't matter which one. Again, I'm just going to take the top one. And I substitute in my value that I found for x to find my y. So 6 plus y equals 9. Y is equal to 9 minus 6. Y is equal to 3. So again, these two equations that I started off with represent two lines. So I found the point of intersection of the two lines this time is 2, 3. So just to go back over this bit again, if we look back at the start, we could have from here just cancelled our y's because plus y minus y will give us 0. And then we have 3x plus x over 2. This would give us 7x over 2. So we could have just used this here. 7x over 2 is equal to, so 9 minus 2 will give us 7. So 7x is equal to 14 when we bring the 2 across and multiply it by our 7. So x is equal to 14 divided by 7. So x is equal to 2. But this is the same as we got before. So it doesn't matter which way we do it. I just feel that some people will be comfortable getting rid of that fraction and having the two linear equations without any fractions to solve it that way. So again, if you want to do that, you multiply every single term by 2 in order to get rid of the 2 on the bottom. So what I recommend doing is just pausing the video, writing out those two equations and going through it whichever way you like and make sure that you get the right answer. So you're looking for x to be equal to 2. Again, you fill 2 into your equation for x and you find your value for y. Okay, so equation number 3. This time we're given the equation of a circle. So x squared plus y squared is equal to 5. And we're given a linear equation. X plus y is equal to 3. What we don't want to do here is we don't want to start multiplying either of these lines by anything in order to cancel the variables in the same way as we did before. So the idea of solving these equations is the same. We want to eliminate one of the variables so we can find x, for example, and then use x to find y. So the first step is to take the linear equation and to make one of the variables the subject. Again, it doesn't matter which one. So for this question, I'm going to let x be the subject. So x, therefore, is equal to 3 minus y. Now I'm going to take this equation and I'm going to substitute it into the equation of the circle. So that's my next step. So everywhere I have x, I'm filling in y minus 3. So that means I get 3 minus y squared plus y squared is equal to 5. So 3 minus y multiplied by 3 minus y plus y squared equals 5. So 3 by 3 is 9. 3 by minus y minus 3y minus 3y plus y squared. When we multiply out our brackets, plus y squared equals 5. Now I simplify and bring everything over onto the left side as well. So we have 2y squared, that's these two terms. Minus 3y gives me minus 6y. And 5 minus 5 when I bring it to the left is going to give me plus 4 equals 0. So to simplify this before I factorize and solve for y, I'm going to divide every single term by 2. So this will just make factorizing a little bit easier. So y squared minus 3y plus 2 equals 0. So it doesn't matter if I factorize at this stage or if I divide by 2 and then factorize, I'll still find the same values for y. So we have a quadratic equation, so we factorize first. Y minus 2 minus 1. I let each factor be equal to 0 and solve for y. So y minus 2 equals 0, therefore y is equal to 2. Y minus 1 equals 0, therefore y is equal to 1. You've got to make sure that you're comfortable with factorizing the quadratics and that you know how to check that you've gotten the right answer. So just to go over this quickly. Once I factorize, I always check by multiplying the inside 2, multiplying the outside 2 terms, and check that when I add or subtract them, I get my term in the middle. So minus 2y minus y gives me minus 3y, so I know that I've factorized it correctly. We don't stop here. Now that we've found our two values for y, we need to find our two values for x. So like before, I just choose one of the equations. It's easier, I think, to choose the linear equation. So we have x plus y equals 3 was the linear equation we started off with. And now I substitute it in my values for y. So first of all, if we let y be equal to 2, we have x plus 2 equals 3. Therefore x equals 3 minus 2, so x equals 1. So I pair these together, so when y is equal to 2, x is equal to 1. So that's one of my points. Now we're going to look when y is equal to 1. So x plus 1 equals 3, x equals 3 minus 1, x equals 2. So again, when x is equal to 1, we have y is equal to, when x is 2, y is equal to 1. So these are the 2 points of intersection. So like with the simultaneous equations before, we had 2 linear equations, we found 1 point of intersection. For this question, we had the equation of a circle and a linear equation, so we have found the 2 points of intersection. So one point is 1, 2, and the other point is 2, 1. So the last part now of question 1. We have x squared minus 6x plus 5 equals y. And we have x minus 1 equals y. So again, it's the same idea. We take the linear equation, we make one of the variables the subject, and we substitute it into the more complicated equation. Okay, so in this case, we have a quadratic. What we also want to notice is that we have 2 equations that are both equal to y. So what I can do is take this equation. We already have y as the subject, and substitute it into the first one. Okay, so I have x squared minus 6x plus 5 equals x minus 1. So I'm going to simplify by bringing everything to the left. So minus 6x minus x plus 5 plus 1 equals 0. X squared minus 7x plus 6 equals 0. We have a quadratic equation. We factorize again. So x and x. So I want to put in the factors of 6 that add or subtract to give me minus 7. So it's going to be minus 6 and minus 1. So this is because minus 6 multiplied by minus 1 gives me 6, so that's our last term. And minus 6 minus 1 gives me minus 7, and that's the coefficient of my middle term. So I know I'm on the right track. So again, we can check this by multiplying the inside 2 and the outside 2 and making sure we get the term in the middle. Now that I have my factors, I let them both equal to 0 and I solve for x. So I have my 2 values for x. So again, I don't stop here. Now that I have my values for x, I need to find my values for y. I'll go back to the equations that I started with. Again, I think it's easier to take the linear equation. So we have x minus 1 equals y. So now we're filling in 6 and 1. So when x equals 6, we have 6 minus 1 equals y. So that means y is equal to 5. So again, the point is 6, 5. And when x is equal to 1, we have 1 minus 1 equals y. So y is equal to 0. So I have the point of 1, 0. So moving on to question 2. Question 2 says that we need to show that the point of intersection of x plus y equals 1 and 2x minus y equals minus 4 is equal to minus 1, 2. So it's just the same kind of thing, except it's a different way of asking it. So we need to show the point of intersection is minus 1, 2. So again, all we have to do is solve them simultaneously and show that we get x equals minus 1 and y equals 2. So we don't need to multiply the lines by anything because straight off our y's cancel because plus y minus y gives us 0. X plus 2x gives us 3x. So 3x is equal to minus 3. X is equal to minus 3 divided by 3. So x equals minus 1. So we're okay with that. Now we fill that into one of our equations. I'll take the first equation, substitute in my minus 1. So minus 1 plus y is equal to 1. Y is equal to 1 plus 1 when I bring the 1 over. So y is equal to 2. So again, we found our x, we found our y. So minus 1, 2 is the point of intersection. So that's all we need to do. Question 3 on the worksheet wants us to change the subject of the following. So the first part, we have AP plus BQ is equal to K. They want us to make P the subject. What I'm really doing here is acting like I'm solving an equation to find p. Like when I have an equation with x, we usually start off thinking, okay, I want x on one side, everything else, all of the other numbers on the other. So in this case, we want p to be left on one side and every other variable on the right. Okay, so I start off, I just leave whatever terms that have p on the left, and I move everything else over. So k is already over on the right. I now move bq over, it becomes minus bq. So now I need to move my a. So because I'm multiplying p by a, that means I have to bring it across and divide. So really all we have to be comfortable with when doing these questions are inverse operations. So if we're adding on one side, we subtract on the other. If we're multiplying on one side, we divide on the other, and so on. So with the next question, we have ab over 3 is equal to b over 2 plus c. And in this case, we want to make b the subject. So what we have to watch out for here is that we have two terms containing b. So again, we start off in the same way. Everything containing b we want on one side, everything not containing b we want on the other. So I'm going to leave my first term on the left, move my b over 2 over, so it becomes minus b over 2, and the c is staying on the right. Now we want to make a single fraction because I really just want one b. So I'm going to put everything on the left over 6. I'll multiply my first term by 2. So it's 2 by ab, and I multiply my b by 3. So if I simplify, I have 2ab minus 3b all over 6 is equal to c. I'm going to multiply across by 6 to get rid of the 6 on the bottom. So I have 2ab minus 3b is equal to 6c. Just being careful that we don't mix up the 6 and the b's. I know my 6's and b's look the same. So now on the left I'm taking out b, which is common to both terms. So this is how I'm going to single b out so I can make it the subject. So now I divide across by 2a minus 3. So b is equal to 6c over 2a minus 3. So just make a note that really when you start off with something that has two terms that contain the subject, you're going to need to factorize really along the way. So you want to just get them on the same side, factorize to get b by itself, and then it's easier to make b the subject. So the last part of question 3. We have x is equal to the square root of a plus b. And we want to make b the subject. So in this case, I want to get rid of that square root sign so I can make b the subject. So I'm going to square everything on both sides. So I get x squared. When I square anything, so if I have the square root of x and I square it, that gives me x. So the square root of x by the square root of x equals x. So this is because if I have the square root of x, that's really x to the power of a half. And I know my rule for that is that if I have this situation, it's x a half plus a half. So these are the rules of indices, which gives us our x to the power of 1. So back to my question. I have x squared is equal to just a plus b by squaring both sides. So therefore to make b the subject, I'm just going to move a to the left. So x squared minus a is equal to b.